Good day everyone. Today's discussion is about the parallel operation of transformer, the reasons as well as the conditions for the parallel operation. So let's start. What is parallel operation? Parallel operation is nothing but connecting primary winding of two or more transformers to supply or source and secondary windings to a common load. To supply more than the rating of existing transformer, parallel connection will be employed. Ang transformer ay kinoconnect natin ng parallel kapag ang rating ng load na nakakabit sa kanya o ang rating ng load na sinusuplayan niya ay mas mataas kaysa sa rating ng individual transformers. So ito yung concept ng parallel operation ng transformers. But if we're going to the discussion of parallel operation of single-phase transformers, it is necessary for us to know the reasons behind the parallel operation of transformers. So here are the reasons for parallel operation. First is to maximize electrical power system efficiency. Ang power system loads ay palagi nagbabari, at para ma-maintain natin ang efficiency ng transformers, we allow transformers to operate in parallel. It's because transformer gives the maximum efficiency at full load. Kapag gumamit tayo ng isang malaking transformer, yung load nito ay palaging nagbabari. So mag-ooperate siya at low efficiency. Kapag naman gumamit tayo ng small units of transformer in parallel, pwede natin siyang i-switch on or off as per load demand at mamimaintain natin ang high efficiency. For example, meron kang load demand na 200 amperes and you have a single large transformer and its full load current is around 200 to 230 amperes. So the transformer is working in good efficiency. For example naman, yung load ng transformer is nag-decrease sa 100 amperes. So yung efficiency niya ay bumaba. So it's better to connect transformers in parallel. Let's say 50 amperes rated transformers and yung load is 200 amperes. So para makuha yung maximum efficiency, ay kailangan maglagay ng apat na 50 amperes rated transformers in parallel at kapag yung load naman ay 50 amperes, remove the other transformer and connect the single transformer. Ito yung overall na pag-increase ng efficiency ng system. You are using the system for what it is designed. Next is to maximize electrical power system availability. So for maintenance purposes, kapag yung transformers ay nakaparallel, pwede nating i-shut down yung transformer na kailangang ayusin o kailangan ng maintenance without affecting the overall system because other parallel transformers in system will serve the load without total interruption of power. Third is to maximize power system reliability. Kapag yung transformers ay na nagsusupply ng load ay connected in parallel, kahit may masira na transformer, a part of the load can still be supplied. For example, you are having only one transformer to supply the entire load, pero na-damage yung transformer mo. So the problem with that is the entire load will get affected. Pero kapag meron kang multiple transformers connected in parallel, kahit may masira na transformer, a part of the load, not the entire load, a part of the load can still be supplied. But take note that power supply may not be interrupted kapag yung shared loads ay hindi magkakos ng pag-overload ng iba pang transformers. And last is to maximize electrical power system flexibility. So if yung power demand is mag-increase in the future, there must be a provision of connecting transformers in parallel para ma-fulfill niya yung extra demand. Dahil hindi economical from the business point of view na mag-install ng isang malaking transformer para matugunan yung lumalaking demand sa power. So parang ang necessary investment of money siya. If naman mag-decrease yung future demand, yung transformer na nag-ooperate in parallel ay pwedeng tanggalin sa system para mabalance yung capital investment and its return. Next are the conditions for parallel operation of transformers. So these conditions are necessary and must be followed when you are planning to connect transformers in parallel. We can connect any two or more transformers in parallel blindly. When two or more transformers need to operate in parallel, they must meet some conditions for efficient performance. Major conditions for parallel operation of transformers are listed below. The voltage ratings and voltage ratios of the transformer should be the same. Transformers should be properly connected with regard to their polarities. The per unit or percentage impedance of transformer should be equal. The reactance or resistance ratios of the transformer should be the same. So let's tackle it one by one. Same voltage rating and voltage ratio. The reason is simply if voltage ratio of two transformers is different and they put in parallel with same primary supply voltage, there will be a difference in secondary voltages. As secondaries of transformers complete a closed loop, there will be a circulating currents. In this case, the considerable amount of current is drawn by the transformers even without load. As the internal impedance of the transformer is small, a small voltage difference may cause sufficiently high circulating current, causing unnecessary power loss. Mahalaga na pareho ang voltage rating and ratio ng transformers na ikakabit natin ng parallel because a small difference voltage may result to a high circulating current that causes unnecessary ohmic losses and decreased efficiency. Also, transformers heats up due to increase in current flow. So, kapag meron kang 11 kV by 22 kV rated transformer, dapat ganun din yung ratings na ikakabit mong transformer in parallel. Second, the connections with regard to polarity. The polarity of all connected transformers must be same in order to avoid short circuit. The polarity of a transformer taken WRT dot notation. That's of all transformers connected together on primary and secondary separately. If the polarity is opposite to each other, huge circulating current flows. So for example, in a transmission line, we have two transformers, the transformer A and the transformer B. And the dots here in the primary and secondary windings of the two transformers is what we call the dot polarity. The dot polarity of primary windings of both transformers are connected in the phase line while the undotted is connected in the neutral line. So, parallel yung polarity ng primary windings ng two transformer natin. For the secondary winding of transformer A is connected in the phase line and the undotted polarity in the neutral line, while the dot polarity of the transformer B is connected in the neutral line and the undotted in the phase line. So as you can see here, hindi pareho yung polarity ng secondary windings ng transformer A and transformer B. So the current that will flow in this loop is a circulating current, which can damage the transformers. So this is not the connections you want to do. It is important to maintain the proper polarity of transformers to avoid increase in current flow and to avoid transformers from getting damaged. So the dots must be connected in parallel and the undotted must be connected in parallel also. So dapat ganito yung maging connections natin. Third, the phase sequence must be identical for all parallel transformers. This condition can be applied only to polyphase transformers. If the polyphase sequences are not same, then transformers cannot be connected in parallel. During the cycle, each pair of phases will be short-circuited. So this is only applicable to polyphase transformers. For example, as you can see here, this is a proper connection for the polyphase transformers. The windings A, B, C must be connected in its proper phase line. So yung A windings, B windings, C windings is dapat connected siya sa A phase, B phase, C phase respectively. So next, equal percentage impedance. The per unit or PU impedance of each transformer on its own base must be same. This condition is also desirable for proper operation of single-phase transformers. If this condition is not met, the transformers will not share the load according to their kVA ratings. So, dapat pareho yung percentage impedance ng bawat transformers na connected in parallel so that transformers will share their load according to their kVA ratings. Now, let's discuss the parallel operation of transformers at no load. Transformer on no load means that when there is no load connected to the secondary side or load side or primary side or source side of the transformer. In figure 36, the primary applied voltages of the transformer 1 and transformer 2 are obviously equal, since both came from the same source. Then, the induced secondary voltages of transformer 1 and transformer 2 respectively at no load. Assume that the turn ratio of the two are not exactly equal. Then the secondary voltage of the transformer 2 is not equal to the secondary voltage of transformer 1, and slight differences in voltage exist on the opposite sides of the switch. Assume natin na ang turn ratio ng transformer 1 and 2 are not the same. Therefore, the induced secondary voltages of the two transformers are also not the same. And yung small difference sa voltages is nag-i-exist sa opposite sides ng switch. If no load is connected to the secondary circuits, the voltages or the secondary voltages of the transformer 1 and transformer 2 will be in the time phase as shown in figure 37. If the switch S is now closed, this voltage difference in the transformer 1 and transformer 2 will cause a current to circulate through both primaries and both secondaries. So kapag close natin yung switch, the small difference in the secondary voltages will result for the circulation of current in the primary and secondary windings. Since turns ratio of two transformers are not exactly equal, this will cause a small increase of current in a line supplying the primaries. If the difference in turns ratio is small, this change in primary line current can be neglected, and it will be assumed that the current flowing in the primaries as a result of closing the switch is the same for both primaries. So, yung small difference sa turns ratio ng two transformers natin will result to the small increase of current in the source side of the transformers. And since maliit lang yung nagiging pag-increase ng current, pwede natin siyang i-disregard and assume natin na ang current for both primaries of the two transformers are equal. Since the voltages appearing at the secondaries after paralleling is the same on both, it is evident that the current flowing in this transformer windings causes an equalization of voltages at the terminals at the secondaries. This current is called a circulating current. Therefore, to find the circulating current is equal to the difference in the secondary voltages of transformer 1 and transformer 2 divided by the equivalent or the sum of equivalent impedances of transformer 1 and 2 referred to the secondaries. The current or the circulating current will log secondary voltage of transformer 1 minus the secondary voltage of transformer 2 by an angle beta. Therefore, cosine raised to negative 1 beta is equal to the sum of the equivalent resistance of transformers 1 and 2 divided by the sum of the equivalent impedances of transformer 1 and 2 referred to the secondaries. Transformer 1 will supply a reactive load to the secondary of transformer 2, and the primary transformer 2 will feed this load back to the primary circuit. This will cause a reduction of voltage at the secondary of transformer 1 and rise in voltage with the secondary 2. So this is the overall operation of transformers at no load. And that would be the end of my report.